Okay. Lesson 5, and this big chapter is kind of broken into two halves, and this is going to be the last lesson in the first half. And we're going to do a quiz on this. It's actually a pretty lengthy quiz on, I think Tuesday is going to be fine. If we wait longer than Tuesday, then you guys are going to start forgetting this stuff. And we're going to be teaching you new material. So we have to do it on Tuesday. I know it's after your grad and the long weekend and stuff. But it's better than doing it later today, or something like that. So we'll do it on Tuesday, and I think I'll make you a deal since it's grad weekend. If you guys do significantly worse than your average, like if you get more than 10% lower than your average or something like that, I'll ignore the quiz for you guys. It'll just be a learning experience for your test then. Okay, but still try. Do study it eventually. Maybe leave it till like the Sunday or Monday, but do study it eventually. Okay, number 5. This one's all about the special triangles, the exact values, and the unit circle. So you have the shortened version is only 3 pages in the package for you guys. So step 1, fill in the unit circle. You can pause this and probably skip ahead about 4 minutes if you know how to do that. Try to do it as much as you can from memory. You've got the degrees on the inside. Put radians on the outside here, if you can remember the radians, and then put all your things around there. If you don't remember how to do it, I'm going to talk you kind of through it for about 3 minutes. There's also a unit circle in your book that you can look at if you want to check your answers. I think I won't fill in the whole circle. You can just check it from your book. First thing you want to remember is the coordinates are always written cos theta, sine theta. Even if maybe you don't remember that, maybe you just have them memorized, but you should always remember that, whether after the fact or before the fact. It's always cos theta, sine theta, so they're always backwards. So cos theta is your x value, sine theta is your y value. And this kind of implies that it's a unit circle with an r value equals 1. So that makes it the unit circle. Does this actually say unit circle? Yeah. Unit means 1. The radius of this is 1. That just makes all of our numbers a little bit easier. Okay, if I don't remember how to fill in these values, I always do it from the 2 special triangles. And I'm going to go over that now in case you want to leave it, but like I said, you can skip over this. So the 2 special triangles are your 45-degree angle one, 45, 45, 90, that's an isosceles, obviously. This length and this length are equal. And then there's the 30, 60, 90. So the other 2 special angles are both in the same triangle. So 30 and 60. Those are our 2 special ones. And then we just kind of memorize. This is the only thing I actually memorize. I don't do it with the unit circle. This one has a rhyme. Well, it kind of rhymes. It's just kind of saying 1, 1, root 2. Basically, the simplest that length could be is 1. Simplest that length could be is 1. And then you solve for the hypotenuse, which is 1 squared plus 1 squared, square root. Root 2. 1, 1, root 2. And then from there you can say, well, the sine of 45 is 1 over root 2, which is equal to root 2 over 2 after you rationalize. Cos of 45 is the exact same number. It is also 1 over root 2 because the isosceles part of it. And tan of 45 is O over A is just 1. Okay, in this one right here, the saying is 1, 2, root 3. I think that's just memorization. 1, 2, root 3. There's no great way to discover that one. And the important thing is, what is the smallest number? What is the biggest number? So the size of the lengths go with the size of the angles. So 30 is the smallest angle, 1 is the smallest length. The largest length is actually 2, not root 3. So the hypotenuse becomes 2, and then the middle one, the 60, is root 3. And then from there you get sine of 30 is equal to 1/2. And you can tell me what sine of 60 is, which is root 3 over 2. You can tell me what cos of 30 is, and cos of 60, and tan. You can read them all from these triangles. So that is how some people do it. They always look on here, but you guys kind of just memorize it. So if you have it memorized, fill those in. It's going to take a bit of time. And it's on page 534 when you're done. Okay. So the only new thing is here that you have the radian measure now. It doesn't change any of these values. The ratios are still the exact same. It's only the angle changes to radian. So only our theta, only our angle measures are actually different in radian mode. All the ratios are the exact same values. Hopefully you know how to interpret this circle well. This is a 30-degree reference angle over here. This is also a 30-degree reference angle over here. That's why these two guys have the exact same values. The only difference is the sign. You have to think which ones are going to be positive, which ones are going to be negative. Same thing with these ones. They're both 60-degree reference angles. Same thing with these ones. They're both 45, and it flips to the bottom as well. So it sounds like you probably did a lot of that last year. Some key things to remember. Sine of theta is equal to y. Cos of theta is equal to x. That's where these values are coming from. Or if you want to interpret them, that's what they mean. Tan isn't on here. So what if you want to know what the tan of 30 was? I assume what you did last year, since you don't have special triangles, is use this identity. The tan of theta is equal to the sine divided by the cos. And we'll work with that a bit. Y over x. Yeah. Sometimes that can be a little bit hard, but we'll figure that out. Okay, so let's try some questions. Don't have a lot of questions to go through. Hopefully this goes fairly fast. Some of these we can just read pretty quickly and directly. Some of these are a little bit harder. Use your unit circle to say the exact value of sine of 300. Well, that is going to be negative root 3 over 2. All I gotta do for that one, I'll just show you guys once in case you don't know. 300 is down here, and sine is the second one because it goes cosine. So negative root 3 over 2. Just reading it directly from there once you have that. Cos of 300, well, that was the first value. It's a half. Tan of 300, ooh, how do we actually do that one? So tan is equal to sine over cos, which means it's negative root 3 over 2 divided by 1 over 2, or times 2 over 1, which equals 2 root 3 over 2. And a negative in the front. Sorry, that kind of got small, but hopefully you can figure that out. We haven't done this one before. Cosecant, so there's only one co in the pair, so this should be sine 1 over the sine of 300, which means you take the sine of 300 and just flip it upside down. So that's 2 over root 3, negative, and then you rationalize. You should be, let's do this slow. So again, I'm going to multiply it by root 3 over root 3, whatever the root is on the bottom. So that makes a 3 on the bottom. Root times root makes just the number, and 2 root 3 on top with a negative in the front. We should be able to do this very, very quick, and we're going to do it a lot this unit. So we're going to practice. Secant of it, well, that's the flip of this guy, so that's just 2. And cotangent of 300 is the flip of this guy, which is 2 over 2 root 3, and it was negative. but then we need to rationalize, which means times by root 3 over root 3. So it becomes 2 times 3 on the bottom. It's 6 on the bottom now. And 2 root 3 on top with a negative. Okay, use the unit circle to find the exact values of, now just some radian measure. Cos of 3 pi over 4. Looking. That should be negative root 2 over 2. I think I'm going to skip some of these. Maybe I'll jump right to D. I think you guys can kind of figure out most of these from the thing. What is cosecant of 3 pi? Well, that's outside of our circle, so we're going to subtract 2 pi from it. That should be the same as cosecant of a single pi. Cosecant is 1 over sine, and sine of pi is 0. So 1 over 0 is undefined. That's the ones that we were doing yesterday. Use the calculator to determine to 4 decimal places the coordinates, the point on the unit circle that corresponds to a rotation of 2/5 pi. Okay. Use a calculator to determine the coordinates of the point. So we just want to find what the cos of this is and what the sine of this is, and then write it as a coordinate. Cosine. So this is just a calculator one. Make sure you're in radian mode. Cos inverse this, write it in the first one. Cos inverse this, write it in the second one. The answer should be you should get that as an answer. And that should be your coordinates, as long as it's a unit circle. Otherwise, these are just ratios, and you would have to multiply them by whatever the radius is. It's actually r times the cos of theta, r times the sine of theta. But in a unit circle, it's just those values. Good. The point, root 2, 2, negative root 2, 2, and negative 1/2 root 3 over 2 are on the unit circle. What's the angle between them? So P, what angle are we at for P? Root 2, negative root 2. That looks like 315 degrees. Just looking for it. And Q, that looks like 120 degrees. If an object rotates, now it tells you the direction to rotate, so it's not doing the shortest possible arc between the 2 points. It wants you to rotate from P counterclockwise to Q. So you can just kind of count it out on your circle. Is it a full line? It actually looks like it might be a full line. 315. A full line would be 135. No, just under 180 degrees. So 180 minus 30, it should be a rotation of 150 degrees. 30 degrees less than a full 180. And what is that in radian? 150 is how many sixths? That should be 5/6, almost all the way to a straight line. 5/6 of pi. Good. Without using a calculator, determine the exact value of log 2 cos of 7 pi over 4. I actually see these questions all the time. This will probably be a type of question you're going to see on the diploma. All you got to do is do it in steps. What is cos of 7 pi over 4? And then we'll find out log 2 of it after. So it's combining two different skills together. 7 pi over 4. That's 350 degrees. We're looking for cos of it, which is root 2 over 2. Okay, now we want to know what log 2 of this is as an exact value. So I think we want to change this into the other form, exponential form. So 2 to the, we'll call that y, whatever the answer is. So 2 to the y is equal to root 2 over 2. And that's not actually going to solve it for us, is it? No, I don't think there's any way. So that was a dead end, actually. Sorry. We're going to go back to this form. We're actually going to combine the inside of the brackets into a single value of 2. And we haven't actually talked about that a lot. So let's look at that. So log of 2, we can rewrite this as root is 2 to the half. And the whole number 2 is 2 to the 1. Now we can actually combine those together by subtracting. So what is a half subtract 1? That should be negative a half, or a root 2 on the bottom. It's going to look something like that. It's actually better to write it as the exponent. If we can get it all to a single exponent, so it's negative a half, that's what we're hoping for. Because now that we have it all as a single argument with a single exponent, that exponent can come down in the front. This is a hard question. I tried some different things. I would have had to play around with this one if I was seeing it for the first time, which I am. So the negative a half comes to the front. And now we've got it good. So log of base 2 of 2 is just 1. So this actually disappears. So the answer is negative a half. Or y if we wanted to. We scratched out calling it y, but yeah. So it's a weird one. 1 mark just for finding out that it's going to be what is log 2 of root 2 over 2. These are we're a little ways away from the exponents unit, but hopefully we can remember how to do that. That is kind of tricky there. Okay, last one on the front of this page. The point lies on the unit circle. Determine the value of theta, where theta is an angle made with the positive x-axis and passing through A. Okay, so this is in quadrant 3, which means that both of our values are going to be negative. Because both of our values are negative, it must be in quadrant 3. Determine the value of theta, where theta is the angle with the positive one. So let's find the reference angle first. And we can actually find it with either of these values. They should give us the same angle. So what is, I'll use this one over here, and that should be the sine one. So if I do the sine inverse of that, of the positive version of it, I should find out what my reference angle is. This is just like what we were doing yesterday. In degrees, it's 52 degrees. In radian, it's something weird. Does it say radian or degrees? It doesn't. So degrees are a bit easier for these ones. When they're not exact values, degrees are easier. And then we just need to find what that is in quadrant 3. Quadrant 3 is 180 plus the 52, which is equal to 232. That's your actual angle. So that one's much easier. Okay, I might not do all of these. Let's have a look at it. Equations of the unit circle. Let P, X, Y be any point on the unit circle as shown. Use Pythagorean theorem to determine the equation of the unit circle. The equation of the unit circle is... What is this actually looking for? Oh, this is looking for x squared plus y squared equals 1 squared. The equation, determine if the following, so every single point that's on the unit circle should satisfy this equation, is what it's saying. So you can actually check to see if things lie on the unit circle or off the unit circle. So are these points on the unit circle? 1/2, 1/2. If I go to the right a half and up a half, is that going to end up on the unit circle? I think not, but let's test it. 1/2 squared plus 1/2 squared is equal to, actually that just equals 1/2. So it is not on the unit circle. 1/2 squared actually makes a quarter. So that's a quarter plus a quarter equals 1/2. Not on the unit circle. It's not far enough. And then we can test the other ones, and you guys know how to use Pythagorean theorem. This one should be, and this one should also be. All of those ones are actually good. This one's actually the interesting one to try, because then you have to square fractions and square things with roots. So I would try this one. I would probably skip B. Okay, the point P negative 1/5 y lies on the unit circle in quadrant 3. Determine the value of y. I actually don't like these questions all that much. I think they're kind of simple. So we want to find out what makes this true. If you take negative 1/5 squared plus y squared must equal 1. So you're going to square this number and subtract it, and then square root it, plus and minus. You should find y squared is equal to 24/25. So y is equal to, you square root the whole number. 24 doesn't simplify nicely, so it's going to be root of 24. 25 does really nicely, it's 5. Root of, sorry, 24, not 25. Root of 24 over 5, and then we simplify that a little bit. That divides by 4, so we pull out a 2, and it should be 2 root 6 all over 5. Should be our y value. Not too bad. I can show you guys these in more detail if you're struggling at all with them. The point P lies on the terminal arm of a rotation angle theta. Determine the exact values of secant theta and cotangent of theta. This P. So for this one, all you have to do is invert these things. This is our cos. So secant is equal to 1 over cos. So all you have to do is flip this guy. It should be negative 5. Cotangent is equal to, tangent is sine over cos. So cotangent is cos over sine. This is going to be, both the tan and the cotangent identities are going to be really important to memorize. They're going to be a big part of our next unit. So it's not wasted time to memorize those. I would spend the time. You could probably find this some other way, but it's good to memorize for next unit anyway. So cos is negative 1 over 5 divided by sine, so times the inverse of this. And then we smush those together, and then we rationalize. So it's going to be 5 over 10 root 6. And then we multiply by root 6 over root 6. So it should be a 5 root 6 on top. And 10 times 6 makes 60 on the bottom. And we're still not done, unfortunately. We need to simplify that fraction. 5 over 60. 60 divided by 5, it's really late at night, 12. So root 6 over 12 should be your cotangent of theta. Okay, determine the value of theta to the nearest tenth of a radian between 0 and 2 pi. Do we actually have... We haven't solved for theta anywhere. We don't actually know what it is. We can take any of these values. Maybe we'll start with this one because it's the one we know the best. So we can say cos equals that. So what is the cos inverse of negative a fifth? And use radian mode to find that in radian. And then what quadrant is it? So that was a negative, and that was a positive. So cos was negative, sine was positive, so that should be quadrant 2. Unless I did that wrong. Oh, it tells you. Never mind. I'm wrong. I assume that was I didn't take this into account. You only get the positive answer, but it's quadrant 3. I just missed a fact. So in quadrant 3, so this one should have been negative. So that's going to change the value of this. Tan is actually going to be a negative times a negative. This is going to be a positive in the end, which I forgot the negative anyway. That was a negative times a negative. So it turned positive. So they're both negative, so it is quadrant 3. It tells you it's quadrant 3. So do that, and then turn into quadrant 3. You should get 4.5 radians in the end. Now you don't actually have to write the word radian there, but if there's no pi in it, sometimes it can be confusing. So if it's something like 4.5, it might be good to write radian rather than have it confused for degrees. Okay, that's it for this one. Sorry, I thought this would be quicker. Some of these questions take a little while, take a bit of figuring out. Lots of practice on this one. And then there's going to be one more video. I don't have the time to make it, so we're going to use Mr. Trimble's video for the next thing. And that really starts the next half of this unit, which is all about trig functions now. Let me get a sheet. Just give you a little warm up. So what we're going to be doing, we're going to be looking at the sine function, which I think starts at 0. Looks something like that. With a max height of 1, a min height of -1, and it travels through a bunch of points. This is 180 degrees, and then it's back to where it started after 360 degrees. And we're going to be looking at the cos function as well. The cos function is very, very similar. It's just a little bit pushed to the left. So these are called periodic functions, and we're going to learn everything to do with them. They have some new features to them that haven't been in any of our other functions so far. So we're going to be talking about period and amplitude, and then we're going to be manipulating them. And there's some, it gets a little bit harder with like the b values and stuff. But it's not actually too bad. I think this is going to be the easier half, as long as you're comfortable with the things we've been doing so far. Then this will be the easier half of this unit. Most people don't mind this too much. Okay, watch his video on his website. He actually has 2 lessons together, 6 and 7. So stop watching halfway through that. We're only going to do 6 today. So it's like a 39-minute video, but I think he's done lesson 6 after like 20 minutes. Okay, good luck.